Hello guys, uh, to the continue of the series, I am going to continue on this playlist. Okay, as last time we had covered up to this point, so further I am going to continue this types of ensemble learning. Yeah, today in the today lecture, I am going to cover the types of ensemble learning. Here, voting ensemble, first voting ensemble, then voting ensemble, then bagging, 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 and the bagging we study for random forest. Okay, and then boosting we read at a boost, gradient boosting, and XG boost, and next stacking. Means overall there are four types of ensemble technique are there. Once again, voting ensemble, next bagging and bagging. In bagging, we read about random forest. Then next is boosting. In boosting, we read about three: add a boost, gradient boosting, and XG boost. And next one is stacking. Okay. Once again, I am revising so that you can get clarity and you and you will no need to be uh, stress your mind to revise and keep in mind this. First, voting ensemble. Next, bagging. In bagging, when we read about the random forest, then boosting. In boosting, we read about gradient boosting, add boost, and boost. And next, stacking. Okay, let's move next. This is the you have to remember this diagram. It will help you understand the things like first so this is feature, this is you have to feature, this is this you have to be remember this model feature 1 feature 2 feature 2 feature 1 like this and feature 2 or feature 1. Okay, and remember that I model 1 model 2 model 3. All these are three models. There we are using three different models. Three different models. Remember one thing, we are using three different models here. Okay, and then here is summation sign. When we combine all these models, this looks like this, and ensemble decision boundary like this. And then this is the final ensemble decision boundary. Okay, are you getting? Is my voice audible? Yeah, this is ensemble decision boundary. Okay, this is you have to remember. Okay, let's move to next page. Yeah, voting ensemble. This is the first type of ensemble technique. Is voting. Now this is the diagram is there. Let me zoom in this. It will be visible to you. Okay. Voting. This is our data set. Remember, first time we are going to learn voting ensemble. And voting ensemble, this is our data set. Okay, so data set means we are providing this M1 model, M2 model, M3 model. Means same data set we are giving to different models. We have to remember it. Okay. Remember, what you to remember? Data set is same. We are giving it different model. M1, M2, and M3. M1, M2, and M3. Okay. Then results of all these models we sound here. Results of this 0, result of M2 model 1, result of this. So we are taking average of all these models. That's it. We are taking average. Yeah. Here we are taking average of this model. Okay. The average, and then this is the final description output. Final classification output. Have to remember process how it is working. Okay. This is the what? Final classification output. What? Final classification output. What? Final classification output. Here we are taking average. Means average of all this. Means average of this. Means this is the zero. Sorry. Let's once again I clear here this. If problem related to regression is there, so they, then we have to take average. If problem belong to classification, then we have to to go to the majority. If that is it is written, if final classification output 0 means majority of output are 0 2. If this same problem, if it would belong to regression, the output of individual model would have this like zero point 0.7, zero point 0.8, 0.75. And we to get the final output, we take average of this like this, and whatever would be the final, that would become our answer. Okay. Are you getting this? How does it is working? Which ensemble technique? Okay, first, once again, I am going to revise you. This is data set. Same data set we are giving to different model. This is M1 model, this is M2 model, this is MN. Okay. You have to keep in mind these things. It will help you to means data set same, different model are different. And if problem belong to classification, then we have to take majority of this. If problem belong to regression, then we have to take average of all individual model outputs. Okay, next move to some important points are written that you have to keep in mind. Here, clear here, here we apply same data set to all models. Models can be different or can be same. Here, clarity in minor model might be same or might be different. If here we are using In this given case, we are using different model but same data set. If we have to change uh, uh, second on the another side, we can use different data set to same model. Means we make sampling of data set, we select randomly and divide that same one to the number of parts, and we that data set we will give to same model. That is why here it is written. Here we can apply same data set to all models, or models can be different or can be same. Okay, I think it make you clarity to concept to remember. Okay, here independently all models are trained on same data. Independently all models are trained on same data. Remember this. Independently, all models are trained on same data. Remember this? Independently, all models are trained on same data. Guys, please remember this. Independently, all models are trained on same data. Hey guys, please focus here and remember this is a very important line and highlight. Independently, all models are trained on same data. Means models are being trained independently on the same data. Okay, the core institution behind the voting ensemble techniques to combine the prediction of the multiple model to produce a more robust and accurate final prediction. Here, this is the central idea of the ensemble, voting ensemble technique. You have, whenever someone asks in interview, you have to initiate from this and then go through the depth as per the follow-up question. And okay, this is the core institution of when the voting ensemble technique is to combine the prediction of multiple models to produce a more robust and accurate final predictions. As we discussed in earlier, same things. This is summarized in the text. The over-institution when the voting ensemble technique is to combine the predictions of the multiple models to produce a more robust and accurate final predictions. Okay, this assumptions behind ensemble technique. This model should be independent in nature. First, in interview, they ask assumptions before initiating any and making any model, means starting model. So here is means here is one assumption is there. Models should be independent in nature. Okay, models should be independent in nature. Once again, revise with me. Models should be independent in nature. Once again, revise with me. Models should be independent in nature. Okay. Second thing is there. Second means assumption is the accuracy of every model must be greater than 50%. Okay. Otherwise, resultant will be worse than the worst. Okay. Remember this point. Means accuracy of every model. The, for example, here we used three models M1, M2, M3. Their accuracy of individual here means accuracy of M1 must be greater than 50%, accuracy of M2 greater than 50%, and accuracy of MN models must be greater than 50%. Means individual. All our three model must be greater than, they must have their accuracy greater than 50%. This is the meaning. The accuracy of every model must be greater than 50%. Otherwise, resultant will be worse than the worst. Are you getting meaning? Accurate devices were nothing you have to remember. So that is why I am keep revising, keep repeating the things so that you no need to be give extra additional time to revise it. Whatever I definitely try to uh, definitely try to you to the means remember all these things in this lecture so that no need to be focused at means you need to be focused at home means accuracy of every model should be greater than 50%. Means accuracy of every model should be greater than 50%. That means otherwise the resultant will be worse than the worst. Okay, this is here they have shared the proof of second assumptions. Okay, why it must be greater than 50%. Here, this is the example to make understand you. Okay, suppose we have three models which have accuracy zero point 0.7 means zero point 0.7 individual of each model zero point 0.7, zero point 0.7, zero point 0.7. Okay, this is in success. A point 0.3 means point 0.3 fail. Okay, now this is the M1 model zero point 0.7, M2 model zero point 0.7. This if we multiply all these three, we get this, and if we multiply this, and this, we get this, and this, and three, this is the technique of dividing and making three from this. Okay, and now suppose our voting classifier works at least two model success accuracy. You have to be focused here. Now suppose our voting classifier wants at least two models success accuracy. Okay, what does it mean? It means now suppose two voting classifier works at least two models success accu- accuracy. Then we get four possibilities. One, two means this, two means this, two means this, two means this. Okay, this. Here in if we add up of this is the accuracy 78.4%. Here it is. So we can see that the accuracy is improved after containing the predictions. Means if we selecting the accuracy of individual model greater than 50% means we have selected 0.7, 0.7, 0.7. The final accuracy is greater than point in of if sorry the final accuracy is greater than the individual model accuracy. Okay, this is 0.78%. Now, now to prove that the accuracy of the model should be greater than 50%. Now, we get four cases where model accuracy is 30%. This case 30%, this, 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 this 30%. Okay, accuracy means the final accuracy and the cumulative effect of the model is worse than the individual accuracy of the model. Individual value accuracy was zero point 0.3, zero point 0.3, zero point 0.3, but the final at the combining result, the final become worse, 0.216 means less than the 0.3%. So that is why it is stated in the assumption accuracy of every model must be greater than 50%. Otherwise, resultant will be worse than the worst. Okay, let's move to another things. Let's move to uh, another page which is less than this. So accuracy should be greater than 50%. This is it. Now bagging. Now we are going to start bagging. Okay, bagging. Bagging means bootstrapping plus aggregation. This will become bagging. Bagging is the word. It's a combination of two words. First, bootstrapping. Second, aggregation. Bagging is the combination of two words. One, bootstrapping plus aggregation. Okay. You have to remember this, guys. This bagging is the combination of two words. Bootstrapping plus aggregation. Guys, you have to remember this. Bagging is the combination of this bootstrapping plus aggregation. Okay. Once again, revise with me. Chant with me. Bagging is the combination of bootstrapping plus aggregation. Okay. Now, this is data sample of data. D1, D2. Here we have different models plus different subsets of data. Here M1 model data D1, M2 model data D2, M3 model data D3, MN model data DN. That means whatever we have data, we have divided in the chunks. Okay, and that and then we are giving this chunks to the different model like this is M1 D1 chunks M1 D2 chunks F2 DD chunks to M3. Okay, are you getting? And this is the, for example, they have assumed the this example of classification 1 0 0 1, and then majority we get 0. Then majority vote. This is it. Majority vote we get 0 because this is the 0. And this is the we have to data to here. This is the process of bootstrapping of the result to the final output we get aggregation. And getting from data to the individual output of the model, it is called bootstrap. The individual output to the final output process we call aggregation. To remember meaning of bootstrap and aggregation, because this is the very hot topic in interview. Very hot topic. is very important. Interviewer ask frequently, and 99 in the 99% in the interview, this is asked. Okay, that is what I'm telling. Remember and be focused. Okay, once again, revise this backing. Backing, revise with me, gent with me. Backing is the combination of two words. One, bootstrapping plus second, aggregation. Okay, then data. Here we are using uh, chunks of data. But as per the given example, we have using D1 for M1 model, D2 for M2 model, D3 M3 model, and uh, they have assumed this is the classification problem. So we have the output of individual models are 1000 and final voting as per the majority of voting. Majority of the output are 0, then final outputs are 0. Okay, this is the process of data to the individual output of model. It is called bootstrap, and from the individual output to the final output process called aggregation. Okay. Every model gets different sample or data. What is written here? Every model gets different sample or data. This is the points you have to highlight in your notes to keep in mind that in this we use if every model gets different sample or data. Every single model get different data. Every single model get different data. What do you remember? Every single model get different data. But to remember, every single model gets different model. Every single model get different model. Every single model get different input. Every single model get different input. You have to remember what? Every single model get different input. You have to remember this. Every single model get different input. Have to remember this. Every single model get different input. Yeah, guys, are you able to connect with me? If you are not getting, please raise your hand so that I could listen your problem, and then definitely I could try my best to clarify your doubt. Okay? Yeah. Next, let's move. In this a random sample of data is a training set is selected with replacement, meaning that individual data sets can be chosen more than once. Once again, read and understand the meaning of this. Means in this random sample of data in a training set is selected with replacement. With replacement meaning that individual data points can be chosen more than once. Are you getting it? That means, for example, to different model, we can give same chunks of data. That is the meaning. Are you getting? But as per the given example, they have given the different chunks, different model. See, for a three model, three different chunks. But this is also possible with bootstrapping. You can give different models same chunks. Means M1 model, you are given even M2 model, you are also giving even chunks. This is the meaning here it is. In this, random sampling of data is a training set selected with replacement, meaning that individual data points can be chosen more than once. Individual data points can be chosen more than once. You have to remember this. It definitely help you in interview. Here I am going to explain was the holistic approach. Means comprehensive, not only for the your learning plus interview, and I definitely guide you how do you respond the question of the interviewer in an effective way so that quality answer. Only listen first to your listen question, and definitely we have to tailor our knowledge in a such a way so that it fulfill the requirement of given question, and we have to make satisfied to satisfy our interviewer. Okay, okay. In this, now backing helps to reduce the variance of the model while keeping the wise roughly the same. Okay. Once again, sorry, I forget to inform you. Whenever you are reading, you have to inform to introduce these two words in your answer when you respond to the question. Why we have to use and what is the business impact of this? It will definitely increase your chance of getting recruited. Why why you are doing W as why? Why we are using, what is the need of this, and how does it impact business revenue or business revenue, impact of this to business benefit, client benefit. In return, company will get profit. Like this business point of view, we have to learn. You have to not only learn the have to not only appear in the interview with the clarity of concept, but you have to business point of view as well as you have to think to make business impact, to make company profitable. Because every company lies such candidate who make company uh, profitable and make business impact. They love them, they listen them, they respect them because they are the people who has done this sort of activities and took initiative in last company. Do mention this in your resume so that it's definitely raise your chance of getting shortlisted. Okay, this is the remember you have to think one thing. Yeah, bagging helps to reduce the variance. You have to remember this. Bagging helps to reduce the variance. Bagging helps to reduce the variance. Bagging helps to reduce the variance of the model while keeping the bias roughly the same. You have to, in this technique, bias remain the same and reduce the variance. Reduce the variance and keep chanting with me. Reduce variance, bias remain the same. Reduce variance, bias remain the same. Reduce variance, bias remain the same. Reduce variance and 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 bias remain the same. You have to remember this thing. Reduce the variance and bias remain the same. It definitely help out to make business impact because they will tell us that what is the why do we use this. We use this technique to reduce the variance and reduce the variance. Okay, and then they ask a follow-up question there. How does you prove it reduce the variance? You definitely I would share answer that can you tell the interviewer. Okay, tagging helps to reduce the variance of the model and while keeping price same. Thank you for the today lecture, and in the next lecture we would continue for the from here. Okay guys, do like and subscribe our channel. If you have any doubt, query, definitely reach out to me at, through any social media. I definitely make my best to clarify your doubt and enhance your knowledge. Thank you.